Don't forget to subscribe and share. Thank you.
All right, thank you so much for joining us again. And in this video, we are going to talk about derivative of inverse sine function. So now that we are talking about inverse, let's look at inverse of the trig functions. We know how to take the derivative of the trig functions, right? Sine will give us cos and blah 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 a lot. So you can also look for that one. But now let's look at how to take derivative of inverse function. So now the first thing that we need to learn from here is, now if y is equal to this, then what is the derivative of this? So here, if we let y to be equal to this, then dy over dx, let me write it what, dy over dx is equal to d over dx of the sine inverse of x. And guess what? This is equal to 1 divided by the square root of 1 minus x squared. We will talk about domain very soon, but here we need to look at the domain of this function because the x value here cannot exceed 1, right? As soon as it exceeds 1, we are in trouble, right? So what we can say here is the domain here is going to be absolute of x should be less than 1. Right? So all the values of x should be less than 1. So that will be the domain here. So know that when I differentiate sine inverse, this is what we are going to get. So my sheet here is saying that the derivative of inverse sine function is given by, so now we write d over dx of sine inverse of x is equal to 1 divided by square root of 1 minus x squared. Great. So this is a formula that we need to learn. It's very, very important in terms of taking derivative. Let's learn how to prove this. Great. Now, if we let y to be equal to if we let y to be equal to sine inverse, then what are we going to get here? Okay. Now, what we can do here is we can find the inverse, right? So if I have something like this, this is also the same as sine y equals to x. The idea is like try to find sine of this and sine of this, right? So it's just like this is not mathematically right, but it's just like finding sine of y equals sine of sine inverse of x. So we learn from inverse function that if we have a function and a function inverse, this will cancel this and it will be left with what is inside. So this is what we are going to get at the end of the day, right? But when you find the inverse like this, now our y here, the y that we have here, is going to be between minus pi over 2 and pi over 2. Yes, so this is what we are going to get from here. Great. Now let's see what we can do here. Now we are going to differentiate this function with respect to x, but we can also differentiate it with respect to y. Anyhow you are going to do it is great. But let's differentiate it with respect to x. And when I differentiate this with respect to x, now here we need to think about the implicit differentiation, right? Implicit differentiation. So I'll leave a video in the description on implicit differentiation. If you want to learn more about implicit differentiation, I'll leave a video in the description section for you to check it out. So what are we going to get here? Okay, fine. Let's differentiate. So I take the derivative with respect to x of sine of y, which is equal to taking the derivative of x with x. What are we going to get here? So when I differentiate sine, we get cos. So this is going to give us cos of y times, now this is implicit. So we are looking at the sine y as this, y. So we are going to use the chain rule here. I differentiate sine, I get cos y, but I need to differentiate what is inside the parentheses. And when I differentiate y with respect to x, we are going to have dy over the x. Great. And when I differentiate x with respect to x, I get the x over x, which is equal to 1. So this is what we are going to get here. Now we are making dy dx the subject as we saw from here, right? We were just finding for dy dx. So let's see that. I will divide through by cos of y to have dy over the x, which is equal to 1 divided by cos y. Now let's go and bring one property that will help us to get to our final destination. Now we know that sine squared plus cos squared of x is equal to 1, right? But because our cos here is in terms of y, I'm just going to change the x to y to have sine squared of y plus cos squared of y to be equal to 1. I want to make y the subject. Sorry, we want to make cos the subject. So I'm going to have this one to be cos squared of y to be equal to 1 minus sine squared of y. Now, don't forget that if I have something like sine squared of x, this is the same as writing sine of x all squared. Great. So now I can write this one as cos of y all squared, which is equal to 1 minus sine of y all squared. So now because I want to get cos, I can take square root on both sides and have cos of y, which is equal to square root of 1 minus sine of y all squared. So I'm going to replace the cos y by what I have here. So this is going to give us 1 divided by square root of 1 minus sine y squared. But the question is, what is sine y? Let's go back. Okay, sine y is equal to x. So I'm going to replace sine y by x, and we are there. This is 1 minus x squared, as we saw from what we had here. So this is the proof for, finding the derivative of sine inverse of x. This theorem here, or this identity here, is very powerful. So this is the process. Now let's practice to find some more example. Oh, okay, we have last thing to do before we get to let us practice. So this one is we want to generalize how to find gene inverse, right? Because sometimes when we have a composite function, we should be able to know how to take the derivative. So what we are saying is that if this u of x is differentiable, then what is the derivative of sine inverse of u? So that's basically what we are looking for. So we want to differentiate this with respect to x, but now sine inverse of u, not x again, right? So now you are not using x. So what is going to happen here is this is going to give us 1 divided by square root of 1 minus u squared. But here we need to multiply it by u prime, because the reason why this one we didn't have anything like times x prime is that x prime is the same as the x over the x, which is equal to 1. So this is just multiplied by 1 that we are not going to see. But we are assuming that when we differentiate what is here and we are not getting 1, then we need to see it. So this becomes a generalized way of differentiating sine inverse. So when I simplify this, I can have u prime divided by square root of 1 minus u squared. And the same thing, this should be less than 1. So this is the generalized way of learning this. So it's good to know that, okay, when I differentiate sine inverse of x, we are just getting what is here, but make sure you know the generalized one so that you can choose your u and you can solve it and it become very fast for you. Let us practice so that I'll show you the skills. So looking at this, we want to take the derivative of this, right? So first I'll write this one down. So that's what I learned. That's what I do when I'm learning. I try to write the formulas down so that as I'm solving and as I'm writing the formulas down, I'll be able to, remember whatever I'm doing, right? So this is 1 divided by 1 minus u squared times u prime. So when I do this, then I compare what I have here with respect to what I have here. This one's supposed to be sine inverse, sorry. Sine inverse, yeah. So I compare this with this because that's what I'm taking the derivative for. So I want to take the derivative of x and sine inverse of 5x. So you see that this one is here and my sine inverse is also here. So my u is 5x. So let's do what is here. So I need u is equal to 5x as compared to what is here. Then looking at the formula, we have u and we need u prime. So let's find for u prime. So what is u prime? U prime is going to give us 5. So now we are going to write this formula here by changing all the u to this and u prime to this. So this is going to be 1 divided by square root of 1 minus 5x squared times u prime is 5. So what did I do? I just did substitution. U is 5x, so I have my 5x here. U prime is 5, so I have my 5 here. So finally, we are going to have something like this. 5 divided by square root of 1 minus 5 all squared. Great. So this is what we are going to get. So as soon as I know this, I can do everything possible with sine inverse of anything that I want to do with respect to. Let's take another one. Let's take another one. Right. Nice. Now we want to take derivative of this. Right. So let's look at this. So this is going to be taking derivative of x. So this is going to be, oops. This is going to be dy over dx, which is equal to 2 divided by sine inverse of x. But remember, here we can use a quotient rule, you are right. But because 2 is constant, I can just take it out, right? Or we can still use the quotient rule. Let's use the quotient rule so that we are free. Okay, let's use the quotient rule. So I'm going to set the top to u and the down to v. So u is equal to 2 and my v is equal to sine inverse of x. Now, the question is, what is u prime? 2 is constant, so we are going to get 0. And what is v prime? Great. So that's what we just learned. So if you know the formula in mind, we know that sine inverse of x is going to give us 1 divided by square root of 1 minus x squared. But know the process, right? Most especially know this, right? So that anytime you are doing it, you do it right. So if I'm using the generalized one, which I'm going to write it here, sine inverse of u, which is equal to 1 divided by square root of this squared times u prime. From this sine inverse, you will see that we can also get this one from the generalized one. So my u is equal to x and u prime is equal to 1. So when I plug in x here, I'm going to have 1 minus x squared, and then u prime is 1. So I multiply this one by 1 and I get the same thing here. Very simple. So let's use the quotient rule here. What is the quotient rule? The quotient rule says maintain v differentiate u minus maintain u differentiate v divided by v squared. Now, because this one is negative, it's not symmetric. Let me say it that way. Is it symmetric? Should I use? Okay, it's not commutative. I mean, you cannot interchange this and this because it's minus. Because if you bring this one first and this one last, if let's assume that I'm using the right formula and I'm getting 2, your answer is going to be minus 2 because of the way you swap this. So that's basically the idea. So pay attention with the formula here. So now let's do substitution and let's go. This is going to be v, which is sine inverse of x. U prime is 0 minus u is 2 times u prime, v prime, which is 1 divided by square root of 1 minus x squared, all divided by v squared. So v squared is going to be sine inverse of x all squared. Now 0 times this will be 0, so we are going to have on the top to be minus 2 divided by square root of 1 minus x squared divided by, but I'm going to use this division sign, divided by this sine inverse of x all squared. And we can just do it, minus 2 square root of 1 minus x squared times 1 divided by sine inverse of x squared. And when I multiply it, I'm going to have minus 2 divided by, I can bring this one first, sine inverse of x squared times the square root of 1 minus x squared. Right. So this is what I'm going to get at the end of the day. That is impressive, right? Yeah, it's amazing. Can't you say it is amazing? It's beautiful. Yeah. So that is question 2. Let's look at question 3. Okay. Question 3, we just need the generalized one first. So sine inverse of u. So I hope you are enjoying the course, right? It's very nice to learn mathematics, and you feel good when you understand what you are doing. It's like the confidence is there. You wish to teach your friends, and practice makes you perfect, right? As soon as you learn something, if your friend is struggling, you just speak, oh, let me just help you. Go step by step, and you'll be able to assess the person. One, you have impacted. Two, you have increased your knowledge. I mean, when you teach, you don't forget what you taught, right? So whilst I'm teaching, because I'm doing teaching, I know all the stuff from undergraduate. So that's basically the bonus of teaching. All right, so now let's go through the process. So I need dy over dx, which is the same as d over dx sine inverse of x squared plus 1. Let's do comparison here. This one is here, sine inverse is here. So what will be our u? U will be equal to x squared plus 1. So we need u prime, and u prime is going to be 2x. Just do substitution here, and then we are done. So let's do it whilst we are writing it here. 1 divided by square root of 1 minus u squared. This is our u, so we are going to have minus x squared. Please don't forget your parentheses, it's very important. X squared plus 1 squared times 2x, boom, and then we are done. So it's very, very, very simple. Very, 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 very simple. That's very, very simple. This is so excited. I'm so excited about this one. Great. Let's find dy dx and let's see what's going to happen here. So first, let me do some small simplification here. I can write this one as 1 over x squared can be written as x to the power minus 2. I hope you agree with me. Great. Plus sine inverse of, so I still have 1 over x squared. I can also write it as minus this. I hope you agree with me. Great. So now let's find dy over dx. This is going to be d over dx in a big parenthesis minus 2 plus sine inverse of minus 2x minus 2. So what I'm now going to do here, now we can take derivative of each function. So I can take derivative of this and also take the derivative of this. But taking derivative of this, we need to use the general rule. So let me just write it. Somebody will be like, you like writing this? Yes, because I want to write it every day whenever I'm solving this, so that I know the exact procedure that I'm using, so that I won't forget what I'm doing, so that anytime I have this formula in mind. So it's good to write it and feel good. So our u here is going to be minus x to the power minus 2. Then what will be u prime? Great. Using the power rule, this is going to be minus 2x to the power minus 3. Right? Great. So now let's go through the process. So you know the reason why I like writing this. So taking derivative of this is going to give us minus 2x to the power minus 3 using the power rule. I promise to leave some, video links with derivatives if you want to practice more with derivatives so that you can also check it in the description. So plus, now let's differentiate this. Now we are going to use the rule here. So this is going to be plus 1 divided by square root of 1 minus u squared, by u is minus x to the power minus 2 squared times minus 2x to the power minus 3. If you want to simplify this, you can see this one as minus 2 divided by x to the power 3 plus 1 divided by, you know, 1 minus. So I can multiply this by this and have x to the power minus 4. And then, yeah, this is the same as minus 2 divided by x to the power 3. Now we can play around this beautiful here. Let me just play around it and let's see what we are going to get. If I'm trying to simplify, you can decide not to do that, but let me play around it. So I multiply this one by this, and I'm going to have minus 2 divided by x to the power 3, this 1 minus, this is the same as 1 over x to the power 4. Let me play around this. This is the same as minus 2 over x to the power 3 minus 2 divided by x cubed. I can simplify this. Now remember how I do my fraction, right? So this minus 1 over x to the power 4, this is automatically divided by 1. So use my hint here. So we go this, this, and this. So first, second, and third to do fractions. So it means that we go this way first, right? So 1 times x to the power 4 will be this, minus, then we go this. So 1 times 1 will be 1, divided by, we go this, which is third, and then we have x to the power 4. So I can write this one, x to the power 4 minus 1 divided by this. You don't need to do this, right? You can stop your answer somewhere here, right? I'm just want to play around this and simplify it to see what I'm going to get. So this is still the same thing as this, minus 2 divided by x to the power 3. And I know that if I have square root of a over b, this is the same as square root of a square root of b. I know people are still watching me. That's great. Thank you for watching. This is going to be times x to the power this minus this divided by square root of x to the power 4. And what's square root of x to the power 4? That is x squared, right? Great. So this is going to give us minus x cubed minus 2 divided by x cubed square root of x to the power 4 minus 1 divided by x squared. One of them will cancel. I just want to stop here. Yeah, nah, let me stop here. Minus 2 divided by, so it's going to be just x square root of x to the power 4 minus 1. I sometimes I do this because sometimes when you are dealing with multiple choice, some of the question they will just simplify it to the, you have gotten this one right, this is right, but, or you have gotten this one right, but this answer is not there. They will just, this one like this, I can simplify it again by, doing my cross multiplication again and just get the final stage. So that is one thing about this. You can simplify, and then before you get your answer from the multiple choice. Okay, so without wasting much time, this is the trial question for you. Try and solve this and leave your final results in the comment section, or you can post your results in Merbs Connect community. Thank you for watching and see you in the next video.